Hello everyone, welcome to my YouTube channel. Today we are going to solve this Math Olympiad problem in which we have to find the value of variable m, and we are given a equation which is 3 raised to power m minus 2 raised to power m equals to 65. Well, I'm not a fan of variable coming into power, but let's see. We do some adjustment and try to get rid of variable from the power. So we have 3 raised to power m bracket, we can multiply the power by 2 minus 2 raised to power m, and for this similarly multiply the power by 2 equals to 65. Also we know a raised to power m bracket n can be written as a raised to power m times n. So our equation will become 3 raised to power m by 2 bracket 2 minus 2 raised to power m by 2 bracket 2 equals to 65. Now let x equals to 3 raised to power m by 2 and y equals to 2 raised to power m by 2. So we get x raised to power 2 minus y square equals to 65. Now we know a square minus b square equals to a plus b times a minus b. So our equation will become x plus y times x minus y equals to 65 can be written as 13 times 5. So on equating we get x plus y equals to 13 and x minus y equals to 5. Name this equation as 1 and this as 2. So on solving equation 1 and 2 we get 2x equals to 18, so x equals to 9. Similarly 2y equals to 8, so we get y equals to 4. Now as we have assumed x is 3 raised to power m by 2, so let's put x equals to 9, so 9 equals to 3 raised to power m by 2. We can write this as 3 raised to power m by 2 equals to 3 raised to power 2. Since bases are same, their power will also equal. So m by 2 equals to 2. So here we get the value of m, that is 4. Now let's substitute the value of m, that is 4, in the given equation to see if it satisfies the given equation. So we have left hand side equals to 3 raised to power m minus 2 raised to power m. So substituting the value of m, that is 4, so we get 3 raised to power 4 minus 2 raised to power 4. On solving this we get 81 minus 16, that is 65, and this is equal to right hand side.